All right. Hello, everybody. Ooh, I see your slides on the screen. That's exciting. Okay. I think we have succeeded. I guess I can start with a comedy routine. Do you know what the most impressive part of Star Trek is? Yep. Yeah. Video conferencing that works on the first try. Okay. All right. Welcome, everybody. Today we're going to be talking about today we're going to be talking about some things we've done to improve the quality of BERT embeddings for document search. And just in case, I assume everyone knows what an embedding is, but I'm always in the clouds, and so I sometimes forget. So just to make it clear, an embedding is a vector representation of something. And what that something is, we'll get into, but that's like kind of the gist of everything going on here. So let's start with some introductions.
Okay, so I'm Allison. I'm a data scientist here at Yext.
And I'm Michael. I am the head of data science at Yext and the first data science hire many years ago. All right. Okay, so agenda today, we're going to talk about just an introduction to the problem in general, some of the challenges that we sort of have faced and are kind of like related to how we decided to solve the problem. So, every solution to a problem introduces its own problem. So how do you sort of cope with that? We're going to go through some tips and tricks we've learned with methods that have been useful for us, although, so take them or not, whatever you want. We'll talk about a conclusion, and then we'll have like time for Q&A. All right. So first of all, why do we care so much about embeddings? The answer is because we have a product that needs to search documents. It is a search engine, and you can buy it. And we want to make it good. So that's why we want to like make these things better. One of the big problems we have is these long documents. Long documents are good to search. They are full of wonderful, interesting facts, such as this paragraph I got right here from the first section of the Wikipedia article about Franklin Delano Roosevelt. As you can see, this is fairly long and covers sort of a variety of different subjects. And we want to find a way to make this search really well. We would like to find ways to generate featured snippets based on this text. We would like to find ways to surface the appropriate paragraph. We would like to find a way to make this entire thing indexable. And it's big. It's a challenging problem. It's a challenging problem. So that's why we care. So how did we decide to, what are some of the problems we have to deal with and how we decide to fix them? So the first obvious problem that comes to mind here is that documents are long. They far exceed the maximum token input limit for a number of deep neural networks like BERT. There are some other ones like Longformer that can have bigger ones, but they're kind of slow. So we want something that can be pretty quick and can search really big documents. You don't want to be doing something like just taking a Word2Vec or fast text embedding and just averaging things out because things are too big for that and you lose a lot of the context. So that's not really good. And we want to understand how things fit together and the relationship. So we want to have a semantic search on these long documents. We have a lot of unrelated subjects in here. So sometimes we might have a long PDF potentially, which could be like 100 pages long. And maybe it's like an instruction manual for a refrigerator. And we want to find a section that's about resetting an ice maker, whatever. But it also talks about the carbon dioxide equivalents of like the refrigerant, all sorts of stuff in there. So they can cover a lot of subjects and be rambly. And we don't necessarily have reliable other tricks like PageRank does with hrefs. Like we don't have that. So we have to figure out a way to solve all these problems. So we decided to segment documents, which sounds pretty simple, but it's not. Plot twist. And that has been a pretty good basis for generating featured snippets, but is challenging in its own right. And we also decided to do embeddings of these documents. So if we are able to take a 100-page PDF, chop it up into a bunch of segments, how do we embed it in a way that makes it most efficient to retrieve and be wonderful. Oh, by the way, unrelated subject, I did look up 18 minutes ago, apparently Elon Musk entered an agreement to buy Twitter. So 280 character tweets, we wouldn't have any of these problems. So, all right.
All right, so what are the challenges with embeddings? Basically, we can break it down into two main challenges. One is that embeddings are noisy. We can take, in our case, words, sentences, documents, and put them into a vector mathematical representation, but that doesn't mean that it's perfect. And two, dense retrieval is difficult, especially in very high dimensions that we're working with. Let's go to noisy embeddings. So first off, we have noisy embeddings. Noisy embeddings is a big issue. Now this comes from two places. One is the model. The model itself can put a lot of noise. The other is, I mean, you can have noisy data, but also the application that you're using. A lot of these models are built for a specific thing, and then you're trying to use them, shoehorn them into a place that they're not intended for. If you have a model that is trained on Wikipedia, and then you're trying to use it on manuals about refrigerators, well, that's tomatoes and potatoes. So not exactly the same thing. The thing is, both word embeddings and sentence embeddings, like BERT embeddings, have these same problems. And some of the issues we see are things like embeddings being really similar to each other that shouldn't be. And that's one of the things that we actually see in this here. This is a heat map of a bunch of different word embeddings embedded with fast text. And these big vertical lines you see in a bunch of these places are where the word embeddings at different indices for a bunch of these different words have similar or the exact same number. And that's not good, because none of these should have the same number across all of their indexes. So that's really noisy. Another thing, just as a hint, heat maps are a great way to look at your embeddings and see if you have noise. There's a bunch of information here that you can very easily see that there's a problem. So, this one's you.
Oh yeah, okay. All right. Suppose you've done these amazing heat maps and figured out that you have not so noisy embeddings, which by the way is hard, but suppose you did that somehow. The next problem you have to deal with is, what do you do about it? If you have some, product managers or whatever interested parties, they're going to want to do something to rapidly retrieve these embeddings from some sort of system. And that leads to another challenge, which is they're big and you maybe have a polynomial time complexity kind of problem. So what you see here is an example of a three-dimensional R tree, which I took from Wikipedia, but I think it's a very good conceptual illustration of the problem of indexing in high dimensionality space. If you remember your database's 401 class in college, then you know that a B tree is a very effective way to index data, but this is much higher dimension, and so you have to come up with something different. Fortunately, it's a very exciting field to be in these days to avoid the polynomial time complexity problem, but you do have to overcome some challenges like the curse of dimensionality. So, and that's a bummer, but you'll figure it out. I trust you. But there's a couple of tools that can also help you with the high dimensionality problem. So, in scikit-learn, if you guys are using that, there are two classes that can be useful for nearest neighbor search. So there's a ball tree and a KD tree. They are pretty effective. They also allow for parallel index construction, which is nice, given that we are now in the glorious multi-core future, because you can't make cores all that much faster anymore. And there's also a library from Facebook that's pretty cool called Face. I think it's Face. And that actually supports CUDA, so that's actually pretty neat too if you have money for GPUs. So that's a cool thing that can help. But you do have a lot of problems to solve with dense retrieval, because number one, you have the curse dimensionality, so you have to be careful about your distance function. Number two, you want to avoid getting yourself into a polynomial time complexity situation. So it's a sticky wicket. But there are some solutions here that you can also consider. One is sort of fusing together the best of keyword-based approaches and semantic approaches. So one tool we've actually used that's been pretty good is, behind the scenes, we use BM25 for a number of keyword indexing approaches, and that allows you to implement what we have referred to as a dual search kind of approach, where you can use a inverted index such as a GIN index or whatever Elastic has, which I think it's inverted index as well, and you can do sparse keyword retrieval based on that, and then you can resort by one of your dense vectors. So that is a way that, even though it's still potentially remains a polynomial problem, you can sort of resort things. So often by combining either TF-IDF or BM25, both of which can be indexed in inverted indexes efficiently, you can work around some of these problems. And we've actually observed in some applications this actually results in better performance. Some cases not, sometimes it's yes, but if you're working on a problem, give it a try. It's a pretty good approach and can sidestep a lot of the complexity around high dimensional index structures. All right. What are we doing about it though?
There are a lot of different things that we've been looking at to actually improve our results. So we have tokenization approaches, segmentation, custom models, retraining methods, and then merging vectors across documents. And we're going to talk about all of these. First up, we have tokenization approaches. So one of the first things that we did was actually move to a UAX29 algorithm to do our tokenization, both for our naive segmentation, which is both sentences and paragraphs, and just as our base tokenization method in general. There's a few reasons for this. One is based on using code, but it has increased consistency across results, and it doesn't use any unnecessary punctuation. It's not tokenizing based on punctuation, and it's not including any punctuation in your results. It's also used by other packages that you might need to interact with, things like Solr, Elastic, so it has increased interoperability. And then can you click the things to animate? So this is an example. This is comparing NLTK and the UAX29 on the same sentence. So you can see we get some weird tokenization. It broke up the word don't, the NLTK did. And we didn't get that in the UAX29. And then it also, NLTK gave us an exclamation point as a token, which we don't want that, that's not a word. So you get increased consistency and it just does much better in a lot of things. And the other thing too is then you're not reliant on your punctuation in your documents being correct or consistent, because that's one thing we see a lot, especially in web pages, is that that's not correct. So we don't want to rely on that.
And the Unicode Consortium actually rules everyone's lives behind the scenes too. It's a pretty serious deal.
They twisted our arm and made us say this. Right, the next thing that we want to talk about is the segmentation. So sentence segmentation is actually a pretty hard problem. And again, we can't rely on punctuation because it may not be there, it may not be correct. It's difficult for a lot of different reasons. We get all kinds of documents and pages. Heuristic methods don't work great like NLTK uses because of the different kinds of documents we look at and the inconsistencies. So what we're using for sentence segmentation is a hidden Markov model based approach. And it's pretty simple. It's only 3 states. Just predicts whether it's the beginning of a sentence, you're in the middle of a sentence, or you're at the end of a sentence. So it doesn't need the punctuation at all. And it works really great for us because not only is it simple, lightweight, but it can be applied to a lot of different languages. It's based on literature, and it also works for languages like Chinese and Japanese, which don't necessarily have any spaces between words or characters. So it's very interoperable. The other thing we have is our HTML-based segmentation, and this works by detecting certain elements and then trying to get context clues about what might come next, so it's slightly predictive. HTML, though, is a lot harder than regular text, so it is still heuristic-based. So it's kind of a mix between heuristic and rule, with the rules and then the predictive. So these two things together give us a lot better segment options, especially with the UAX tokenization. And I think we have an example next.
So, okay, let's say you have segmented a document into a bunch of sentences. What then? Especially if you have this nice long passage again from the Wikipedia article about FDR that I so nicely prepared here. One of the problems is that not everyone necessarily breaks up their text into coherent blocks that talk about the same subject. So in this example, I quite subjectively decided that this paragraph should be divided into 3 different topics. The first one about the re-election, then one about World War II, and then a purple one about the Lend-Lease program. So that's kind of an interesting problem because, if you were to embed all of these together, just one big old blob, you might have some problem with your embeddings. They may not be very meaningful potentially. And this is a situation where we have found that developing a standard data set for evaluation of all the different hyperparameters you have to tune here is very powerful. And we actually focused on US presidents, even though it's not very inclusive. It does have the benefit of being pretty easy to reason about precision and recall. Like, for example, if I type in a sentence like, who is the president who served 3 terms in office, and I don't get back the blue section right there, I'm knowing that something's not working correctly, and I can start to tune my algorithm a little bit. So this is a really important tool that we've sort of built in our arsenal, and it's tricky, but if you can find a good way to narrow it down to something. We also use the script from the B movie quite a bit. So movie scripts are also another good source. The guy who did that, his name is Bowen, so maybe there's a coincidence there. All right, let's talk about retraining. One of the other things that makes a real big difference here is how often you can retrain your models. No model is ever going to be perfect, even if you can spot the problems with really good visualizations inspired by Edward Tufte. So we make heavy use of this sentence transformers library. Sentence transformer is they basically implemented a couple of additional layers on top of a core BERT that makes it much more powerful for predicting like next sentence kind of tasks. They have a couple different loss functions implemented in there. So there's like a contrastive loss function, there's a cosine distance loss function, and you have a number of convenient retraining functions. So I was speaking with some people from Square earlier today at the meetup about how we sort of handle these problems. And the honest truth is that all good data science really starts from a good data warehouse. And if there's any product managers in the audience, I see you. You got to keep adding things to the warehouse, and then having a really good team of people who can go through and review things. It's not fun. It's not necessarily the most exciting, sexy thing to do, but it really does make a difference, especially if you have a good way to go through your warehouse, spot the regressions, add that to your retraining set, and then retrain the model. And these guys make it really easy. So if you're working with embeddings and you want to make them better, like retraining is going to get you a lot of good benefit out of it. Also, they allow you to insert arbitrary base models. So you can, if you have enough training data on your own, you need to support a number of clients in different languages, most likely. You can just change the base model and get a lot more good out of it. And so we've been able to increase the languages supported by our embedding models into, I think we're 6 or 7 now. And it's because we can just swap these things out pretty well, then get the thing going and have the good warehouse. And, so it really makes a big difference. So this is a great library. If you're not already using it, highly recommend it.
Yeah, in fact, custom models are a big deal. BERT-based generally isn't enough for most applications. So either training your own custom models or switching out your base models is a really good way to get improvement in your results. If you need to change your base model, there are a lot of international options now. MPNet is really good in English. When we switched over to MPNet, we observed about a 15 to 20% improvement just from switching from BERT-based to MPNet. Part of that is the Sentence Transformers team released the MPNet fine-tuned on about 1 billion examples. So that's a huge model, and that's a big increase from what BERT-based is trained on. We also have models in multiple different languages, and those we also fine-tune, make changes to, and customize as needed. So that's something that you always have to keep in mind is you don't just take whatever model that you start with, you always need to make your own changes to it. Speaking of making changes, most of these models, average pooling is the default. That may not be a great option. There are a lot of different things you can do. Wavelet pooling is a good one to look at. Other places or other certain layers, you may want to look at different pooling options. It really depends on what you're trying to do with your model and what layer you're looking at. Internal layers, things like wavelet pooling, more complex pooling options are good. As you get towards the outer layers, simpler is better for pooling. So always test and play with things. The last thing I have to talk about here is merging vectors. So merging vectors has been a big thing in keywords. Word embeddings people have been adding them for a long time, but we have been testing merging other kinds of vectors. Sentence embeddings, we can merge those together, we can merge those with keyword vectors and get some really interesting things. So merging multiple embeddings of different kinds into a single embedding is really useful. There are multiple ways to do this mathematically. Generally, again, simple is better. Average is usually the best option, but cross product, dot products, inner products, sometimes simple addition is a good option as well. It really depends again. So part of that is based on the application and part of it is based on how you're segmenting. So with sentence segmentation, average is really good. But again, just test things and make smart decisions based on what you've already got in your system.
For a question?
Yeah.
So we have a question from Stephen McInerney. When would you use vector cross products for merging?
So with the cross products, I have found in the testing I've been doing is when you're using two sentence embeddings, cross products work better. Whether you're doing.
Would you just repeat the question? Sorry. So the question was, would you please repeat it? When would you use vector cross product for merging?
Vector cross products for merging. If I understand this correctly.
When would you use vector cross products for merging?
When would I use vector cross products for merging? My analysis in looking at merging vectors, I've found that cross products work best when you're working with two sentence embeddings. So if you're trying to merge multiple sentence embeddings, that's usually when cross products work best. Yeah. Yeah. Two different sentences. They could be embedded different ways, but they have to be the same length. This one's a little tricky. It makes perfectly good sense when you're talking about like adding keywords together and averaging those, but it gets a little bit more wiggly when you're talking about sentences.
A question?
Sure, though there's a couple of objectives. One of the things that we wanted to look at was if we're looking at searches where we have a semantic search, but we have certain keywords that are more important, we want to merge those together and have like an enhanced vector. But the other thing is too, if you want to take two embedded sentences and get those into one embedding, so say you have two searches that are linked in some way and you need a merged embedding to have one embedding at the end.
Like, for example, if you wanted to compute like the average or merge together like all of the queries a user did during a session, for example, that might be an example of when you want it. We're also going to talk more about this in a minute as well, or later on. But you know, if your AWS bill is too hot and you need to find a way to reduce the amount of storage, there's other options besides just merging vectors, but that's another case where it might be powerful. Like if you can find a good trade-off between, like, you know, if you take your 1,000-page PDF and break it up into sentences and you don't do something to merge those vectors, somebody's going to complain. Rightfully so.
So Stephen Ho asks online, is the cross product here referring to making it a tensor?
So it's a mathematical cross product. It doesn't really matter how they're stored. I think that should answer the question. Like basic, if you go back to your basic vector math, that cross product, dot product, all of those, yeah, that's what we're doing, cross products, those ones. You could have it as a tensor if that was how your vectors were stored, but it doesn't matter. Yeah, it wouldn't. Okay, cool.
Okay, so he follows up, sorry, is cross product only defined for 3 dimensions?
So there is a way to get around that. So generally a cross product is defined in 3 dimensions, but because we have a multi-dimensional vector, generally with BERT, it's 512. There are mathematical algorithms you can use to like take triplets of those coordinates and compute it that way.
There's another question.
It's not the most straightforward thing. I probably should have put a picture of this one.
If this is getting too far in the weeds, especially the next question, just say so.
I think this might be getting a little far.
I'll say the question anyway. It comes from Leo. Are we talking about a Hadamard element-wise product?
Yes. That is a very similar, that's one technique that you can use, yes. All right, I think we should move on to storage.
All right. So once you have all these nice fancy vectors that you have computed in some way, you have to think about, how you're going to store them. And as I was mentioning earlier, BERT does produce a pretty high dimensional output, and you need to find someplace to put it. You can also use this to speed up your search problems too, which is a big deal. So we looked for a while at a number of ways to do dimensionality reduction. And we tried a couple of techniques personally. We tried principal components analysis, as well as another method called UMAP, which apparently is one of the best these days. And we didn't really see any clear benefits from doing so. We just saw not a tremendous reduction in dimensionality, but also loss of information until we discovered that in the sentence transformers library, they have a nice little thing where you can drop your remote. They have a nice little, not so well documented parameter here that lets you change and add on any additional output layers at the end of the model. Thank you. And this actually worked out really well for us for reducing our storage, because we added on a couple of dense layers at the end of it, experimenting with some of the different pooling methods that Allison was mentioning earlier. And we were able to get we had about 90% of the performance of the full size vector in only 64 dimensions. So if you are in the situation where you have a lot of documents or embeddings, and to answer your question, if you want to go sentence wise, there's a lot of benefit you can get from this. And especially if you're using this for a ranking kind of procedure, not necessarily is this the exact answer? There's many ways that you might benefit from taking advantage of just adding on some additional dimensionality reduction vectors. And that turned out to be the best approach. All right, the last thing is, suppose you spent all this time working on this project and you're very happy with it, and you now have your fancy, demo on GitHub or whatever you're doing. You need to figure out how to get it into probably some sort of product. And one of the things that we found to be very useful while working with these vectors, after going through the training procedures and refinement procedures we described, is using our labeled data set to construct sort of a variant of an ROC curve that helped us optimize some of our thresholds. So if we said we wanted to return search results, only if it was relevant according to some definition of whatever that means, we would have to find out what that entails. And to do this, we basically plotted, on the x-axis here, you have a cut threshold, and then we have a F1 score on the y-axis. And we found basically here that there is a difference in performance between these three different models. But in all cases, the optimal return value, or the optimal value, is around this point right here, which turned out to be about 0.75. And one thing I also want to show here is that this is the benefit of the retraining procedure. So these three different series represent three different iterations of our model. We changed the base architecture. We adjusted we increased the amount of data that had been labeled. So the retraining has a pretty real effect. And the difference between these two lines here, the blue and the green, is about 20% in some cases, or 15 to 20%, depending on sort of some of the details of the query. So we found this was a really good way that made a difference. And if you want to use this technology to make an impact, you have to find a way to get it into whatever product or whatever feature you're working on. And so this is a really good way to make it real for somebody. So you can't forget the last steps of your project.
All right, so some takeaways here. First thing is think carefully about tokenization and segmentation concerns. The project that you're working on will dictate what methods you choose. Always develop some kind of benchmark data set, whether you develop it yourself or you use something that's existent, that help you balance your precision and recall in the manner that you need. Updating and fine-tuning models is essential, as is changing out models as needed, and always consider custom layers. And finally, wrap it up and get a practical implementation out there, because otherwise the rest of your work will have been for naught. So, are there any questions?
I have a question from Leo online. How much extra data do you create? Isn't it very expensive? I'm not sure about the context.
So in general, we have found with, if you're using a pre-trained BERT or BERT size model, we found that a magic number, that's where you start to have an impact of your training procedure, is around 10,000 examples. For our purposes, we, fortunately for us, have a team of people that are supervised by a linguist. And for this particular project, we actually use our embeddings in tons of places in our system. So we actually have invested a lot more. It's on the order of a couple 100,000, I think. But it's made a big difference. It's hard to get to scale of the size of the data set that the sentence transformers people put into the MPNet model that they fine-tuned. but like you can definitely get a pretty big impact, especially if you look at sort of related problem queries. One of the things we've noticed in looking at like clusters from these embeddings is there tends to be like common failure modes, if that makes sense. So certain queries do not have a big like cosine distance between them and where we would expect one. If you prioritize those for labeling, you can do a lot to sort of improve the model. So you would like to, it is good if you can implement like you as a person, like seek the residuals of your model and then prioritize that for retraining. Triage, yeah.
It follows up to clarify 10,000 queries.
In the example of the sentence transformers model, you're going to want a pair of 2 sentences.
Okay, so people who are attending remotely, if you do want to be enabled to ask your question live, use the raise hand feature. I have another question that came in online from Keith. I didn't quite get what you are using tokenization for. If you are using transformer models like BERT, they tend to use word piece tokenization.
Well, you want to take this one?
Yeah, we replaced that.
The other thing is you want to use this stuff for the generation of your like coherent segments, right? So whether you're doing sentence segmentation or topic segmentation, like you still want a tokenizer there.
Yeah, and that's the thing is the UAX 29 tokenizer. The main place that we use it is in the sentence and topic segmentation because that needs word tokenization at the basis of it.
And it's really handy if you have like Elastic anywhere in your stack, wherever you're working, and you want to pay homage to the Unicode Consortium. Question back there?
Sorry, I'm not quite loud enough. I was wondering if you go a bit more into like how you develop this like feedback process, how much of it like was initially like in-house, exploring any like third-party human in the loop companies like Scale or whatever else like might be on the market that's good these days.
Yeah, great question. I would say that we have spent a lot of time agonizing over that. It is not a straightforward answer. I think my first answer off, just in general, will be like anything is better than nothing. But then the next question I think you need to consider when you're looking at these kinds of stuff is what level of like domain expertise do you expect out of your annotators? And we decided to go in-house because we wanted to we expected more of our annotators because there's often a lot of context that is useful for processing whether any like given pair of sentences are in fact textually entailed, which is what you need for this labeling procedure. So to give an example of something related to that, we had a client who was a hospital chain. And we also had a client who was an auto parts store. For scalability reasons, we can't run a bajillion copies of every model in the critical path of processing a user's query, but we needed the model to do better. One example of a problem we observed was if you typed in like joint replacement, you would sometimes get some pretty bad predictions because that could be ambiguous depending on the context of the query. In our example, which is a search engine case. So we found by actually adding in some additional information to the model prediction about what the name of the business was and the industry of the business, it actually increased our accuracy by about 10% in absolute terms, which was huge because a query like joint replacement, the model would be like, well, is that a healthcare procedure or is that a car part? I'm not sure, it could be both. And it is depending on the context, but if you get that additional layer of information for the model to fit to, that helps quite a bit. So my answer to that would be, if you have those kinds of problems, then you might want to consider in-housing. If you think that's not a big deal, you can probably go with one of the scaled vendors. Another major consideration to think about is how you are going to deal with annotator agreements and disagreements. It's good if you can have like one annotator label something and then someone else review it. Or maybe another one you do is you say, I'm going to have 2 people, and if they disagree, I throw it out. So blind consensus is a method you can choose. That's where you start. But it's really expensive because you're going to throw away about half your data. So depending on how you want to handle all those questions, will impact your decision to whether you want to go outsource it to a company like Scale or do it in-house. I would also add, like every data scientist should label some of their own data. Like it is not fun, but it really helps you get better at your problem. Yeah.
We're going to take an online question from Keith, who can turn his video on and unmute yourself, and you should be able to pose your question.
Hey, I was the one that asked the question about the tokenization. If you don't mind, I just had a follow-up. So I was just curious, like why you decided to use your own tokenization, and if that's the case, that's the input into the model. So does that mean that you trained the transformer from scratch, or did you still use the pre-trained model and like fine-tuned it with a different input, tokenization input?
Good question. Basically, we kept the vocabulary for the model the same, but we used our tokenizer to construct the segments ahead of time. So that's how we did it. That having been said, we are approaching we want to get to a critical mass where we can start using our own tokenizers and our own vocabulary. So that's up next, but we're not quite there yet. But we use it mostly for the segmentation procedure, or actually entirely for the segmentation procedure.
Cool, thank you.
All right, so we're going to take a question from the live audience.
So when you fine tune the models and revising the layer, what tool do you use to track it? And if you use weight and bias, can you provide any benefit that you gain from it?
Is that weights and bias the software package?
Yes.
We don't use that actually. We just used notebooks and graphs, and we also put all of our training logs into a database, and we can analyze things. And we run a retrain every night, and we look at the performance over time and just plot a figure once in a while and pick the best performing model. We do not use weights and bias.
So how do you remove the layer and add the layer to it? How do you track it?
I'll show you here. Let me go back. So if you're using the sentence transformers package, if you look here, when you instantiate a new sentence transformers, you can pass this additional parameter here, modules, which basically allows you to inject whatever additional layers you wish. So if you wanted to add like one-dimensional convolution or average pooling or max pooling or wavelet pooling, you can do that by adding a series of additional layers to the end of the model here. In our case, with one of the best performing ones we found, we used a multi-layer perceptron going from 768 down to 64 dimensions, and we found that performed well for us.
We have an online question from Antonio. Are you mapping the embeddings on a knowledge graph like ConceptNet? Wow, that's a good thing. That's a very interesting question. I wish I could say more. We're working on it. It's a really hard problem. Any other questions in the live audience? Or if you are online, you can use Q&A, or you can raise hand to be promoted to a panelist to ask your question live.
Do you use any long-range transformers like Longformer or ETC or Performer?
That's a great question. We would like to do more. I think that we didn't really mention this, but we wanted to do all of this like with a 50 millisecond deadline in the critical path of a user query. So that kind of constrained our options to some of the smaller ones for now. But we're looking closely at that stuff. Another thing we've also found a lot of benefit from anecdotally is just using generative models to pre-label data. Which structurally has like kind of an adversarial approach where you have one model label something, humans verify it, and then you use that to train another model, and you can sort of get a virtuous cycle of positive reinforcement or something. I don't know. It's good. So we're looking at it, but we have some pretty serious constraints about getting things under a deadline.
Yeah.
All right, we have an online question from Oswald Campisato. Did you consider other models such as Roberta?
Yeah, that was one of the things we found a lot of benefit from, was swapping out some of the base models. We were with BERT base for a while, mostly due to its, again, speed. Roberta we found to be a little bit too slow for our purposes in the critical path of a user query, but MPNet has the same architecture as BERT, so not many more weights and parameters. And dramatically increase performance. So I would recommend MPNet over Roberta all day long.
Right, and we have now, Leo should be enabled if you want to unmute and start your video to ask a question. Leo?
Yeah, thank you for the interesting presentation. Quite a few useful details. I still actually have a follow-up question regarding the embeddings and the tokenization. So you mentioned that you redefine tokenization, but if you completely redefine tokenization, you actually have to retrain your embedding layer. So is my understanding correct that you sort of are using the higher level tokenization basically to you get your tokens, but then you concatenate them back, and then you apply the same word piece tokenization on top of that?
Did you say tokens? Or I'm sorry, I didn't quite.
I mean, there was. I'm actually following up on the follow-up question regarding the word piece tokenization. Right? You say that you don't change vocabulary, right? But if you change the tokenizer, there is no choice. You have to change the vocabulary.
Correct. So to answer that, we are not changing the input token IDs that go into the model. We would like to do that pretty soon, but we're not yet there. But we use the UAX29 tokenization to tokenize the input. We use that for the establishment of sentence and topic segments. And then we reconcatenate together. That goes into the model. And
the segments.
Yeah, the segments.
Yeah. So once we actually get the UAX29 tokenizer is what's used to get either sentences or paragraphs, basically, that are then sent to the BERT models. And that we're looking into redoing the whole thing and replacing that internal tokenizer, but that's not in our production yet.
Got it.
The other
Thank you.
thing is that we do also use Elastic for a couple of places as well, and that also uses UAX29 tokenization. So we had a lot of difficulty integrating with engineering teams, like on defining what a token is, and WordPiece has a whole different thing. So being able to agree as a group of people working on a problem on a standard tokenizer was also beneficial.
Yeah. Okay. Yeah. I got it. Thank you. So that was my thought. So the keyword is retaking. Basically, you have to rejoin those. Yeah. Cool.
Yes,
got it. Thanks.
Correct. You do have to rejoin. Correct.
This is all working. Do we have other questions in the live audience?
Cool. Thank you. Hey, so you mentioned that you use an HMM for the sentence splitting. How did that perform when you had uncommon abbreviations that end with a period?
It doesn't really care. So the good thing about the way that the HMM works is that because it is predictive and it looks at the states of the words around it, uncommon abbreviations mostly get kind of swept into the rest of the sentence. So even if it's something you haven't seen very often or ever, as long as the rest of the sentence around it looks like a sentence, it'll get swept in. The other thing too is that we actually remove the punctuation because we don't use the punctuation. So the fact that it ends in a period doesn't stop it. So the abbreviation is the only issue, and we have some logic in the HMM itself.
And
at those states.
A quick follow-up to that is, I don't know if this is too niche, but did you notice any issues with long noun phrases that have a lot of abbreviations? Might throw it off.
That does sometimes throw it off a little bit, but the adjustments that you can make in the states based on the research for the spaceless languages like Chinese actually help with that a lot. So adjusting your starting weights when you do the training helps with that.
Gotcha, thanks.
Was there also a paper we read about the HMM that we could maybe share? I think we had a good reference, right?
Yes, I have a reference that I can share for that.
Also about HMM, so is it based on the embeddings, or are you doing it from scratch based on the tokens, or how do you do it?
You can do it either way. I find that it works better with the embeddings, but it can also just work with the tokens, which is how the original paper did it, was just with tokens. But I implemented using the embeddings.
Would be super cool if you could share the paper. That would be.
Yeah,
Thank
for
you.
sure. Yeah.
Hello? Hello? I'm here.
Hello.
Perfect. Hi, I think there's some probably confusion on my part, but I've read articles about taking word embeddings and then averaging them to get a sentence embedding. And the things that I've read say that that's not a good strategy. So again, it's confusion on my part. Is that, what are your thoughts?
We're not averaging the words to get a sentence embedding. We're averaging embeddings together and keeping them in the same state. So if you're averaging 2 word embeddings together, you're keeping a word embedding. If you're adding a word embedding and a sentence embedding, you still have a sentence embedding.
Okay. Okay. The other quick question, this issue of long documents doesn't address long sentences, where the limits, I think, is 512. And let's say you chop it up and you might have 10 parts, but then the 10th part might reference something in the first part. And so you lose that information. So that's not solved.
Run-on sentences. That's part of where the sentence segmentation comes in, because the sentence segmentation doesn't care about the punctuation. We can sub-segment that sentence into smaller sentences. And then if we know the original document had it as multiple sentence and we want to return the whole thing, we can return the whole thing. If we want to just give back a snippet of a sentence, we can do that too.
Yeah, and I think the point you raise about supposing you have a long document that is segmented in a variety of pieces using whatever method, you want to know about interactions between those segments.
Yes, yes.
Yeah, that's a really interesting problem. We've got some ideas around that, but we haven't solved anything yet. But yeah, that's an interesting one. It's really tough. Yeah.
And just to add, I don't think it happens all that much in English, but I was thinking like a language like German, you can have massive sentences. And so that I think could be more problematic for them, perhaps.
Yeah.
All right. Thank you very much. Appreciate it.
Yeah, you're right. It's a really challenging area. And we are looking, one of our areas of active research right now, kind of unrelated specifically to embeddings, but just in general, is like, how can we do more to extract relationships between entities within a long document? But that's it's hard. It's hard.
Sure. Yeah.
Hopefully we'll have something cool to talk about in, I don't know, a year, maybe if not sooner, but it's a tough problem.
Excellent.
Tough problem.
Thanks again.
Right. I have another online question. This one is from Achari Barada Youssef. Why did you use HMM models over more conventional sequential models used in NLP like RNN and LSTMs?
I tested them and the HMM works best. That's one of the things you have to test things. Just because when something is, conventionally used doesn't mean it's going to work the best for your application. And again, we have to apply something with a lot of different types of documents, and we have to have something that is internationalizable to a lot of different languages. And Japanese being one of them. LSTMs don't work well with languages like Japanese. So that's a big stopper right there. So that kind of
There's also a lot of prior
off
art.
the table.
There's a lot of prior art with people using HMMs for segmenting logogram languages already. So it's a pretty well-proven technique for this specific application.
Yeah, and it works well with poorly written English, which is something you find a lot in things like documents and product pages and things where grammar isn't necessarily the most important thing. So that's very helpful for something like that, where you don't have a well edited piece of English.
And certainly as an artifact of like scraping HTML as well. Like if you take a UL element out of a web page and like you try to there's no punctuation on that. So like you need something that's going to be robust to that.
Great. It's really nice to see this level of engagement. We'll go on for a few more minutes. I have another question from the live audience.
Following up on that, I was wondering, like, you mentioned that you're relying on a lot of heuristics for the HTML right now. I was wondering, like, to what extent have you been able to integrate them in a more like consistent way with the neural network processes that you're using right now, whether like there's some like elements that can be codified in, or like you mentioned like H1 and H2 tags. I was wondering about like li, div, whatever tags, like can that information be factored into the model framework you have right now?
Yeah, it's a great question. We're working on it. I think one thing that's instructive about this field is that a lot of people who need to extract data out of web pages treat it as an OCR problem. So I think that should tell you something about like how difficult it is. If you decide the best way to do this is to print my text and like character recognize it. So
There are some really badly formatted.
Yeah.
I scrape a lot of terrible websites. They're
Yes,
they're
yes,
horrifying.
you know.
Yeah.
So
It's
have
really
you
bad.
considered OCR?
We're working on it, as you said.
Somebody sent me, I think it was Michael actually sent me a really good paper about this subject. There are some people out there that are approaching it as a graph kind of problem. Like, can you predict like which branches of this tree contain relevant content? I think one of the challenges is that like HTML has so like you theoretically could make every character a span. And I bet you if you're making your web pages in Word 97, it probably does that. And you still have to find a way to scrape all that out. So that's a tough one. You know, if there's ways to get what you want out of like some simple heuristics, that can get you a long way, especially if you can make up the difference in another part of your pipeline, if that makes sense. So yeah, we found good results. Granted, some of the stuff we need to process is reasonably well-formed like markdown. So you can be like, oh, here's a pound sign followed by a list. Like that's probably good. So like if you're parsing like some sort of like modern React thing, like, oh, forget about it. It's like not going to work. So it's hard.
Agreed.
So this had been a longstanding problem with PDFs as well, where yeah.
Yep. Yeah, it's a problem.
Do we have any other live questions?
Oh, sure. I don't want to honk. Yeah, I was just wondering, like, you mentioned that you started off with a model that worked very well in English, and then like eventually like had to migrate to something else that was more international. I was wondering, like, what were the biggest roadblocks you hit that like motivated that transition?
I think we have a lot of demand in those languages from our clients. So that was a good one. The roadblocks are getting people who like those are, you know, to use a word here, low resource languages, even though like German being considered low resource is insane, but it's hard to get a lot of models to get started with, and getting a sufficient volume of clean text to train a base model is no small undertaking. So it's really hard to get these things going, but this is why the feedback cycle of triage or, you know, gradient fitting, residual fitting, so to speak, but like in the manual way is very helpful if you can do it, because you can rapidly get things like bootstrapped. So my advice there would be like whatever you can do to get started. And, you know, compared to 2018 when BERT was first published and Hugging Face was just getting going, like your options now are a lot better for base models to get things rolling. You know, even in Japanese and German and Italian. I think we just rolled out a model called Bertino or something like that, which is neat. So I appreciate all the funny names people are coming up with. So just get started with something and then start to retrain it over time. And the tools that exist now for retraining are really slick. And there's a lot of nice things you can do with it. So it's a very exciting time to be working in the field. And canvas your office for native speakers of whatever language of interest.
Hey, yeah, thank you. I had one question regarding like context windows. So it seems like you're losing a lot of information if you, let's say, just embed like a single sentence without like its context. Then like, so imagine like you can embed like a sentence, the surrounding sentences, just pull out the embeddings for just the sentence you care about. Have you guys tried this, or is it just like a latency issue to do this like document or something? Or
yeah, I mean, I think that's the motivation for the topic segmentation project. Yeah, like if we can find a way to like, you know, if you have to go sentence by sentence, like, so we have some stuff we're working on, but we're not allowed to tell you about all of it. But if you go sentence by sentence, like that's a place to start. But if you can find a clever way to combine coherent sentences together, that would be pretty good. The problem is that sometimes people ramble, so you have to find a way to, you know, chop things. But if you can figure that out, like that Wikipedia example I showed, where there's one paragraph where they talk about the re-election in 1940, and then like a bunch of stuff about World War II, then they go into economics and like, you know, Lend-Lease and the economy. So like how do you build an algorithm to chop that stuff up is important. At the very bare minimum, if you can just, you know, if your data is small enough, you can just, you know, do it on a sentence basis and throw it all in a database and keep track of the order, maybe. Like that could be a way to do it. But you could probably also do something naive, like, you know, go 2 at a time or something like that. Like unless you have 512 token run-on sentences, which is improbable.
out of interest, have you guys tried this sort of comparison where like you have like, let's say you're embedding out of like sentence BERT with this like sort of like contrastive trained embedding.
Can you say that again?
You have this like embedding out of sentence BERT, right? Where you have this contrastive trained embedding. What about just like naively, let's say like embedding the whole entire text with like BERT and then just pulling out the embeddings for just like the tokens you care about, averaging those as your sentence embedding. They're like context aware.
Yeah, it's a good idea.
There is a method that does something similar to that uses a rolling windows, because the longer your document gets, the harder that is to do and the more computational power you need. But basically what it does is it uses a key split and then you make windows of different sizes, and I'm forgetting the name of the method. But
like
people published a paper on it.
Was that the DPR paper?
I don't think so. But basically it just takes a whole document, does that, and then splits and just recursively just looks down until it finds the like smallest
TPR.
topic that fits your need.
TPR from Facebook does something like that, you know, and it might also be kind of interesting if you're looking for brainstorming ideas here. It might be kind of interesting to try like a hierarchical method, like HDB scan or something like that. Might be a cool way to do it. Where if you said, I'm going to treat each of the embeddings of this paragraph of sentences as like a collection of points, and like try to learn like a linkage tree, that'd be kind of cool. It doesn't seem too hard to do.
Very cool. Thank you.
Yeah, I was wondering if you have any methods or ways you're thinking about an asymmetry between your query and your documents, and if there's any way to handle that.
Oh yeah, it's a bummer.
It's
a bummer. I would say, you know, hopefully you have enough data. In our case, like I said, we're doing search. So hopefully you have enough data where there's like long, like reasonably complete sentences. We've done some things in the product to encourage that, like adding a voice transcription button and like nice suggested queries. So that helps. But that does sort of lead to a feedback loop you may be concerned about. So that's one thing. We also have been using generative models to write questions and then have humans grade it. But again, thankfully they're different architectures, so we feel like kind of okay with like having, for example, a T5 or a GPT-3 generate questions, then use that for labeling a different model. But I do think you have a little bit of risk there in terms of like, you know, computers taking over in Skynet and all that kind of stuff. So it gives me a little bit of pause, but we have dabbled on that. And I think with a human in the loop, if you can get a human to sort of, you know, keep an eye on these things and not let them go off the rails, I think it's all right. And that can help bootstrap something.
Thanks very much. We're going to stop there. We've been gone for a good amount more than an hour. So thank you very much, Allison and Michael, for the talk today. And thank you very much for Yext for hosting us today. It's been great to meet in person again. I think that once we got going, that the hybrid model worked out okay, including having people on screen. So I will make a pitch once again for meetup talks. I would love to do this frequently, whether it is in-person hybrid taking place in Washington, D.C. or New York, or possibly Boston as well. I have a couple of companies in Cambridge that are willing to host, or whether it's a pure online meetup. I do have an online meetup that's pending with speakers from who are in California, but we haven't nailed down the date yet. That should be happening in 3 to 4 weeks. So thanks to everyone who has attended today, whether in person or online. I believe there's still pizza left for people who are here in person, and that we're welcome to stay for a bit more. So once again, thank you very much.